Right, so we are now going to continue the forces, right? Questions on forces. So this is one of my favorite questions. I've done this like so many times. And I'm not talking about the question. I'm talking about the cleaning of the windows. Have you ever cleaned windows before? No? Okay, so if you were to clean windows, you're going to use a device like that. And sometimes these devices have got these little dots there, right? Handphones sometimes also have. You know, it's like a rough surface. You don't want like a very... Okay, your this pen also have. Why did they make this thing come out? Boop, pop out. It's the same reason why they have dots over here, right? Why do you choose this pen? Maybe it's like when you hold it, it's more comfortable. Your hand is like resting on what? Pillow, right? Oh, your fingers is like resting on pillow. So happy, huh? They want to fall asleep. Okay, right? That's for this particular one. But here, definitely it's not for the hands to fall asleep because it's trying to clean the window. So what do you think is the purpose of these raised dots? Wait, that's not the first question. What property of the glass prevents it from being scratched by the rubber strip? So the first one is that it is hard. So the glass is harder than the rubber. Okay, so it's hardness. It's about hardness. Do you understand hardness? Okay, ability to scratch, right? So the second part is why are there so many raised dots? Why do they have so many raised dots?
Friction.
Yeah, so the raised dots increases the surface area, hence increases friction. So that you don't have to write the rest, huh? So that the person holding it will not, you know what, sleep when cleaning the window, and therefore he can do a good job and you'll pay him his salary, you know, and then he can play Pokemon. Huh?
Like it's a magnet, then it's like on the
Yeah,
other side.
yeah, so those are the other type, right? That's another type. But this one is manual. The guy has to do this so that he can have money to buy handphone to play Pokemon. Right? Okay, next one. Okay, so this is the helicopter. So why did Daniel carry out the experiment 3 times? Aiyo, this type question so many times. No. Why? Tell me why. Why? To ensure the... Yeah. Right? We take the average. So give a possible reason why the distance travelled by each of the helicopters of the same mass was different for each tribe. Why is it different? You see, same mass, but every time he tried, it's like first one is 220, 250, 241, 350. It's all haywire, no? He launched the thing, then phew, fly, phew, all different. Why? So it's actually a bad experiment because the data is weird, right? But so why is it that it's weird? So you got to look at how he launched the thing. How does it launch the thing?
It could be different.
Yeah, he's supposed to pull the elastic thing backwards, right? Right. So one possible reason is that he could have pulled it back a different distance. Okay, so what we say is that one reason could be that Daniel, which is your brother's name, could be that Daniel did not pull the rubber band. Is it a rubber band? Yeah, it looks like a rubber band. The launcher back the same distance for every attempt. Okay, so he did not pull it back the same distance. What happens if you don't pull back the same distance? You let go, you'll fly. Yeah, some far, some near, right? Next one. Oh, so fast. Okay, so Luther applied an increasing amount of force on material W, recorded the amount of force. What property was being tested?
The thickness. What?
Effect.
The
Strength. Okay, because it's braking. Braking is about strength, right? So The strength of the material was being tested. Okay, so one of the variables made this an unfair test. Which variable made this test unfair?
Different color.
Why?
It just have to keep one variable different.
Oh, wrong. What property of material is being tested? The strength. Okay, so he should have kept the thickness the same. The color is not going to affect the amount of strength. The thickness should be the same because he want to test which material is the strongest, right? Is it W, X, Y, or Z the strongest? So he should keep all the thickness. So the thickness of the materials should be kept the same, right? So next, Newton wanted to test the relationship between the variable in B. Okay, so now change, right? Now he changed. He want to test whether the thickness affect the amount of strength. So what should he keep the same? He should keep the material. He should use the same material, but with different thickness, right? So just use the same material but with different thickness so he can check how it is. Do you understand the second part? Right? Great. Okay, next one. Jay Woo, wow, K-pop star. Okay, why the block slide downwards after Jay Woo released it?
Gravity.
Yeah, so the gravitational pull or the gravitational force pull the block down the slope. Okay, see and stop before point C. So he used another material and it's not moving. Then he said that there were no forces. Is that true or false? That's wrong, right? We know JU is wrong because it's JU. So why is it wrong? He said no forces, no? Is it true that there's no forces? Yeah, very good, right? So there is always friction, no force. Okay, what else? What other force is always there? Yeah, gravity, right? So gravitational force is also constantly acting on the object. Right? These two forces are always. Yes? You got a question? No. Okay, this is on the object, not the object. On the object. Next one. Good. What do you think? You can put outside, never mind, right? Because I can also eat also. Is it nice? What's that? Sweet or? Huh? Food. Okay. 小吃, you see? Talk about food, 小吃. Conducted an experiment. This is the extension thing that you're talking about, right? So based on 小吃's result, did the volume of the block affect the amount of force acting on the spring? Did the volume affect the amount of force acting on the spring? Does volume affect the spring? No. Okay, no. Okay, no. So how did we come to the conclusion? You see the two volumes here? Block X and Y have the same volume but different extension, right? So block X and Y both have the same volume but different extensions. Okay, so that gives us the conclusion that it doesn't work. Okay, so Xiao Zhu repeated the same experiment using another block W. The mass was 25 grams. Volume was 100 cm3. What could be the value of H? Yeah, so this is the extension thing that we have to figure out. The mass was 25 grams. 25 grams. If it was 25 grams, what is the value of H? Since volume don't affect, right? So we look at 25 grams. Okay, so 25 grams is 0.5. Yeah, this is 0.5 cm. So at the end of the experiment, the tray was empty. Xiao Zhu observed that the H was 0. Okay, what's the property of the spring? Okay, so you remove the thing, right? The H was 0, so no extension. Okay, you empty the tray, then no more extension. And the conclusion was, what's the property of the spring?
Flexible.
It's elastic. Okay, the spring is elastic. Yeah, I'm gonna find out which school is this. Whoever came up with this is like wait. Next. Elastic. Right? Flexible. Flexible is not the best answer. Spring is elastic. Okay? Okay, so next, what can Kai conclude about the experiment? Okay, so this is another one of those different surface. You see, in the first part here, bigger what? Surface area. The second one, smaller surface area. Okay, so big one, big surface area, small surface area. What can Kai conclude? You see, the smaller surface area and the larger surface area doesn't affect. Okay, very good. Because most students will say that, oh yeah, big one affect, but not true, no? So Kai can, Kai become Jai. Kai can conclude that the surface area does not affect the amount of force needed to move the block. Right? So it does not affect at all. Okay, next. So Kai wanted to choose a suitable type of floor tiles, and he did another experiment as shown. Now we have a significant difference, right? So which type of floor tile should Kai use? Is it the A or B? This is smaller, larger, this is wrong. This should be A, B. A or B, right? Right, so this should be A or B. Right? Huh? What do you say?
A.
Why?
Because
You want to use a bathroom or no? Bathroom.
not sleep.
Yeah, so not sleep and which one? B what? Because more force. Yeah, so he should use B. Why? Because more force is required to move the tiles in the experiment with tile B, hence it shows that it has the most friction, which is good as bathroom tiles. So you will not slip and fall when you are in the bathroom because it's going to be terrible.
That's how my auntie's mother died.
Are you serious?
She fell and hit the head.
Your auntie's mother is like your grandma, you know.
No, like my domestic helpers.
Oh, it helps. Oh, I see. Yeah. Yeah, so I wasn't thinking of that. I was thinking more of like if you have diarrhea, and then you go into the bathroom and then you're like, oh, I want to use the toilet, but you slip and fall. That's terrible. Okay. Yeah. So sorry to hear that. Huh? Next one. There's another one. Okay, so fill in N or S to show the poles of magnet X. Okay, so we have Audrey set up the experiment shown the mass of A and B are 85, 140. X is fixed to the table. Okay, so you see the whole thing is balanced. X is fixed. This guy is fixed to the table. So this is 85. Okay, how about here? 140. So by right, if there's no magnet, what happens? This thing is supposed to tilt to the left. But then some clever dude put a magnet here, and this whole thing is balanced. So what does this tell us about?
This is N, this is S.
Very good. So there's attraction, right? So this is N, and this is S. Hey, I can write. You know that. Next. So explain how object B is balanced by magnet A. Object B. Okay, how does magnet A balance object B?
Because you tilt, then after you attract, then you pull.
Yeah, so we say the force of attraction pulls magnet A downwards. Hence, lifting object B upwards, which balances it. Right? So balance. It's balanced. Okay, next. Now B is replaced by a similar size object C with a mass of 70 grams. Okay, what's going to happen? Now to balance C, fill in N or S. Now what's going to happen is it's going to drop this way, right? So yeah, very good, right? You didn't fill in. So this has to be S, and this is N. Wait, it's a finger writing. Well done, next. Okay, this should be the last two questions. Okay, we have a metal bar W. Okay, this is north and south, like that, right? North and south. So styrofoam. Now this thing turn this way, right? Which means that this should be. Oh, what's going on? And south, like that. What just happened? Okay, how do I get rid of that? Excuse me, can someone tell me? Where's the undo button?
There.
Ah, okay. Well done, right? So we know where's the north and the south. Okay, so what will happen when Q is brought close to R? Introduce 3 different bars, PQR, suspended them, different sizes. Okay, so W is here, right? Okay, now what does this tell me about W? Is it just a piece of metal? Magnet. It's a magnet because it will shift direction, right? It's a magnet. That means W is a magnet. Now you have PQR. You put like that, huh? So this P is a piece of metal. R is a piece of wood. Q is a piece of wood. R is a magnet. So what will happen when Q is brought close to R? Nothing will happen. Because it's a piece of wood. Nothing will happen. Why? Because bar Q is a non-magnetic material. right? We do not know if it's a piece of wood, could be a piece of plastic, but for sure it is a non-magnetic material. Can? So P is a magnet. Can or not? Can you say P is a magnet?
It's attracting.
Yeah, but can you say for sure it's a magnet? No. Okay, very good. So we disagree. We strongly disagree with her. Why? So P is attracted to W, which means it is a magnetic material, but need not be a magnet. Right? So how can we tell it's a magnet? When it repels. So it is a magnetic material for sure, but it's not a magnet. May or may not be a magnet, so we don't know until we can see it repel. Okay? Next. So the diagram shows Mr. Aries climbing the stairs. Oh. So it's the first time this Mr. Aries is climbing stairs, right? It's first time. He has never climbed stairs before. So he realized that it takes more effort to climb up than go down. Because it's the first time he ever climbed stairs. So could you explain to him why?
You have to go against gravity.
Yeah, so when climbing up the stairs, he is going against gravity, which is pulling him down, hence he needs to exert more force as compared to going down. Okay, so we have a wooden thing with a rust with a metal material. What's the function of the rust with the material?
Fall down.
Yeah, increase what? Friction. Increase friction so that the elderly will not slip and fall. I'm trying to see what it is. Can we see? Oh, M&M's, I'm guessing. By the sound of the plastic thing, I think M&M's. No? Cannot be up. How about the last one? Okay, after several years, some patients actually slip and fall. What's the reason?
The roughness.
Yeah, the rough strips worn off after years of use.
Just have an elevator.
Another reason is they didn't put the handlebars there. You see that? You know, they should have put the handle. You know, it's very dangerous to have a staircase with no handles, you know. Right? So people can slip and fall very easily. Okay, so I'm going to stop here for today. We still have quite a bit, right? Can we see how much more? Yeah, still quite a bit. So forces is a big chapter. We're going to take some time to be able to do them. Okay, but it's very interesting. Once you understand them, it's very easy to do. Okay, that's all for today.